Every single day, millions of tons of discarded bottles, containers, and packaging are dumped into open-air landfills across the globe. What doesn't stay on land inevitably washes out to sea, gathering into massive, floating islands of debris that choke marine ecosystems. Meanwhile, to power our cities and vehicles, we spend billions of dollars building massive industrial rigs to drill deep beneath the ocean floor just to pump up crude oil. We are drowning in hydrocarbon-based waste right on the surface, yet we continue to drill deep into the earth to extract the exact same chemical energy. In early 2026, a young inventor named Julian Brown successfully powered a high-end Rolls-Royce with a liquid fuel made entirely from old plastic bottles. The experimental fuel he created boasted a massive 110 octane rating, easily outperforming standard premium racing fuel. But if you've ever seen a plastic container melt near a fire, you know it produces thick, black, toxic smoke, hardly the clean combustion needed to make a luxury engine purr. Achieving this level of performance requires a precise chemical rearrangement. The process extracts usable energy from the solid trash without ever setting it on fire. The process starts at the recycling plant, where everyday plastic waste is thoroughly washed and ground down into uniform flakes. The very first scientific hurdle is heat. You have to get the plastic hot enough to break down its structure, but if it catches fire, it turns into useless ash. To control this, the plastic flakes are loaded into a specialized, tightly sealed steel reactor chamber. This cross-section shows the atmosphere being vacuumed out of the chamber until the oxygen meter hits zero. With the oxygen gone, traditional combustion becomes physically impossible. The plastic simply cannot catch fire. By completely eliminating oxygen from the equation, we bypass destruction entirely and enter a state where we can manipulate the plastic on a molecular level. At the core is microwave pyrolysis. Energy waves hit the chamber, instantly spaking the internal temperature. Under this intense heat, the rigid chemical bonds holding the solid plastic polymers together fracture. These fractured chains skip the liquid phase, vaporizing directly into a heavy hydrocarbon gas. Generating this extreme heat requires massive amounts of electricity, so the entire reactor system is powered entirely by green, renewable solar panels. The combination of extreme heat and zero oxygen creates the specific physical environment required to isolate the hydrocarbon components within the plastic's molecular structure. Once the plastic is converted into a heavy gas, it is funneled out of the reactor and pushed through a series of specialized cooling tubes. As the gas hits these condensers, the sudden drop in temperature forces it to revert back into a liquid state, resulting in a dark substance that closely resembles natural crude oil. From there, this raw oil undergoes an advanced refining process, filtering out impurities until it becomes a premium, high-octane fuel ready for high-performance engines. In just a few highly controlled steps, a discarded soda bottle is broken down and reconstructed as a high-grade energy source. That 110 octane rating means this new fuel, dubbed Plastiline, easily withstands massive compression inside a sports car engine without causing dangerous engine knocking. But you can't drive up to your local gas station and fill your tank today. Right now, production is entirely experimental and strictly limited to small, non-commercial batches. This comparison shows why plastic waste is so difficult to process. While standard oil passes through simple filters, plastic oil must navigate a complex maze of gates to remove the specific dyes and chemical additives found in household trash. Creating the base fuel is a solved problem. The real barrier to everyday use is engineering a way to purify this complex chemical soup safely and consistently on a massive commercial scale. We also have to address the environmental reality of how this fuel is consumed. Because Plastiline burns identically to regular gasoline or diesel, it still releases carbon exhaust directly out of the tailpipe. However, because the heavy industrial manufacturing process is powered by solar energy instead of fossil fuels, the overall net carbon footprint remains lower than traditional oil refining. Plastiline is not an overnight cure for global warming or a total replacement for crude oil. However, it demonstrates that with precise engineering, our most persistent waste can be converted back into a high-value resource.